Welcome to Zero Knowledge. I'm your host, Anna Rose. In this podcast, we will be exploring the latest in zero-knowledge research and the decentralized web, as well as new paradigms that promise to change the way we interact and transact online. So today we are here for a special little episode. I'm still on break, but I wanted to return for a end of year 2024 look back and a looking forward episode. I'm here with most of my co-hosts. Tarun, Guillermo, and Nico are here with me. Hey guys.
Yay.
Hello.
Yo, what's up?
We are only missing Kobe. I think we've actually done this almost every year. Sometimes we've broken this down into 2 episodes, doing like a look back episode and then a look forward episode. This time we're going to try to combine the 2 of them. We're going to try to focus less on like a month by month play by play, which we did do once, and a little bit more on like general themes, what went well, what didn't go as well, and what could be coming in the future. So I put together a few little actually, ChatGPT helped me put together a few little questions about the past.
What went well? Anna using AI in 2024.
Yeah, exactly. Who would have thought? That's really a change.
Well, we used it in 2023 when we like modded my voice.
But it was more. You were less gave in. You didn't give in to the Borg. Then you were like freaked out by the Borg.
I was scared.
Yep. AI was not sparking joy, but apparently it sparked enough joy that you actually used it like not ironically this time, which is impressive.
Yeah. Okay, so here's the first generic ChatGPT question that I was able to get. What were the most significant advances in ZK in 2024? I know that's a bit generic, but we're starting around there. So I wanted to start with research, actually. What did happen this year? What are kind of like, in 2024, what are pieces of work, research papers, like implementations that stand out to you, but more on this like researchy cryptography side?
There was a lot of movement in like hash-based snarks and a lot of like new developments. So we had the whole Circle Stark saga.
Oh, wait, that was this year. Shit. It feels like a year, like more than a year ago. That's crazy.
Are you sure that wasn't end of 2023? Because I'm pretty sure I had Ulrich on.
So I checked before.
Oh, you did? Okay.
Yeah. They did their first like investigation into M31 in 2023. And we had these like Reed-Solomon codes over M31. Mm-hmm. And then in 2024, they had the full-fledged like Circle Stark and the Stu implementation come out. You also have like Stir Whir are things that came out in 2024.
Yeah.
More recently, there was Blaze. So there's a lot of work in like this area of research.
And that's good.
And that is good, yeah. Well, actually, it also sparked a whole other narrative this year, which was the hash versus curved and like hash-based snarks or curve-based snarks. And this narrative like hash has won.
Wow.
And I think that's interesting to look at, revisit, chat about. I don't know.
Yeah.
I remember, I mean, we had an episode, I believe, with David Wong where he had a hot, spicy prediction that he was like, hash-based snarks are dead. And I was like, are you sure about that?
Complete contrarian take.
Yeah, he should have waited till the end of the year for that one.
Yeah. I mean, no, I think it was a great prediction because it was kind of fun to get into the weeds of it, why the thoughts were. But it's funny because it's like, these are not like things that are like exclusive, right? Like they're not, like you don't just get to like work on one and to the detriment of the other or something. They're like kind of like just different things. So it's funny seeing some wars around them. Anyways.
Yeah, and they coexist all the time. Like every single rollup we see on Ethereum rolls their proofs into like a Groth16 or like a Planck proof.
Right.
So they do coexist, and they're almost like they need to coexist.
And it seems like it got pretty spicy at the end here, right? With the Google announcement. I don't know. Tarun actually probably has some context on that, more context than I do.
Yeah.
I haven't actually paid attention to the thing, but
Well, I just thought the marketing in the blog post was a little bit incendiary. So
Yes.
I feel like that already turned me off to like how accurate the result was, because the paper is like a 4-page PRL paper, and it's like doesn't really say that much, or at least the original paper. I mean, the Nature paper is also a little bit marketing-y. So it's like, I'm sure there's something there. I'm sure that Google is slightly exaggerating, and like the multiverse thing in that blog post was embarrassing. Like also citing David Deutsch for that. Like, are you fucking kidding me? You're not citing like Heisenberg or Dirac or someone who like came up with this shit actually, and not a guy who wrote a pop sci book. Like the entire thing is like pandering to like Twitter Huberman Bros, like that article. Anyway, sorry, that was my.
I want to revisit this because one of the questions I'm going to be asking is like a little bit more about what went wrong or setbacks or challenges, and I think I've been meaning to kind of dig into what is real and what is not real, and I'd love to do it there. Just bringing it back, though, to the research of 2024. I actually just dug it up on my ZK Summit 12 slides. I did this like history of ZK research, like in the intro. And for 2024, this is what we actually had. This was created in, September, October. Maybe it's changed. But we had Polymath, Stack Proofs, Plonky 3 came out this year. Circle Starks, which you were right, came out this year. Garuda and Perry, which I don't actually understand, but it came out this year. And both Stir and Whir, like you had mentioned. Those were the like Fry kind of, this is people starting to again go back into like Fry and seeing if we can improve on what was created back in 2018, 2019.
So I was actually going to add, to close this like hash versus curve thing, there were also developments in the curve-based land this year, including, as you mentioned, Polymath, Garuda, and Parry, which are all snarks that are smaller than Groth 16. Interestingly, I'm not sure their like on-chain verification cost is cheaper, but the proof itself is smaller. And I don't know, that's a cool development in itself.
Nice. Something I just realized I didn't have on here, but would maybe want to include. I did kind of another bonus episode on my time off with Dan Bonnet, and he talked about some like lattice-based snarks. And that, I don't even know which works those are, but that maybe, could that be something of like a 2024 highlight?
Yeah, the big one that came out in 2024 was Latticefold, which is sort of applying the ideas of Hypernova and using lattice-based commitment schemes. And so Dan goes into a bit more detail about how it works in that episode with you.
There's been some like other interesting developments on lattices, which I was quite cool, which is Greyhound, which essentially like does this cool thing with Labrador, which is from 2023 and it's pretty fast. I don't know. I remember seeing the numbers and they were kind of crazy, although I haven't looked super deeply into it. But it's like a Ligero-like based scheme, except using lattices as opposed to like standard hash functions. And that gives you a bunch of nice properties. Anyways, I don't know. It seems like, you know, they're starting to peek out a little bit under the surface, like these lattices and things like that. And, you know, we'll see where it goes from there. Although I do think next year, I do have a prediction on that for next year. But anyways.
For the lattice-based snark starks, they, at least in that episode, I understood that this makes snarks more compatible with FHE technology potentially. But like lattices, that's broader than just FHE, right? Like I'm assuming this all of a sudden opens it up to a bunch of new tech.
Yeah, absolutely.
Does it also open it up to like AI stuff, like ML stuff?
Potentially.
Tarun's making a face.
Yeah. Yeah, I'm like, that's not really related. That's
VC
not really
talk. Get out of here.
No, I'm just like, I don't know. Those are very unrelated.
Oh, they are. Oh.
I mean, the reason we're using lattices is because we're trying to find hard problems. We're trying to find things that are easy to set up for computers and hard to break. And that's how we do cryptography. And so, yeah, that's how we do FHE. That's how we can do ZK. Some people are looking to do like obfuscation.
Crucially, most post-quantum things are lattices.
Oh, I
like
see.
The most
Okay, so it's that.
best known post-quantum things. Yeah.
And actually, there was a fun paper that came out this year, a big scare. So in April, there was this paper called Quantum Algorithms for Lattice Problems, in which the author Yilei Chen says like, hey, here are algorithms that break these lattice problems, like quantum algorithms that break these problems.
Wow.
And for like a period of 1 week, everyone was freaking out because this is a very respected author and everyone was reading through the paper, trying to find a bug, being like, holy shit, is everything broken? Do we have to give up on lattices? Especially because lattices were being used in a lot of the NIST standardization efforts for like post-quantum encryption. And so 9 days later, someone, reaches out to Yilei Chen and he updates the paper saying like, hey, there's actually a bug and I can't fix this. So the paper is still up for inspiration if people want to think about these problems. But lattices are not broken yet, as far as we know.
Ooh. Yeah. Do you think they will be, though? Was that like a hint that they could be?
It was a close call. I think there were a few people trying to find bugs, and Yilei fixed a few of them. So it started to feel like maybe there's nothing we can do here. I don't know these things well enough to have any form of intuition.
And what I think was really, for me, interesting in that whole debacle, there was this magical like organization that happened I don't mean organization like the sense of like an org that does stuff, like an organization of like organization of humans that just like happened. Like, I don't know, Discord servers were launched and people were just like, the Discord server was only talking about this paper, and like the channels were like different pages of the paper and different theorems, and people would discuss the like it was super interesting to watch, like how people spontaneously organize themselves against major results in kind of like post COVID, right? Like, I feel like these things kind of happen a little bit in weird niche esoteric channels, but seeing it be so public, right? Like outside of labs, like outside of, just people who work at Google and know math or whatever, we're just spinning up these servers and be like, dude, come join. Like, we need whoever we can get to understand this stuff. If you can explain it, great. If you can't explain it, done. Like, let's just try to figure out what the hell this thing is saying, like how to do it. And it was very fun seeing that. And it's kind of an interesting, where's the future of like research going, I think, which is what was kind of limited to, Rube's the blackboard and whatever, the standard physics department feels to be like a very global thing now. And that, I don't know, it was just as an anthropological exercise, it was very fun
I think it helps that it was a theoretical problem and a theoretical break.
For sure.
Like, had it been concrete, I think this would have been like locked up, Department of Defense, like on it.
Well, I think there's also this philosophical issue that comes with generally quantum algorithms that I think is like worth pointing out as to why it takes forever to figure out if these things are correct or not when someone posts them, which is like most cryptography, whether it's algebraic or whether it's hash-based, I'm separating those very broadly. I know there's obviously overlap, but like there's sort of a sense in which they're very like strongly discrete objects. There's a certain number of objects, and there's a certain subset of those objects that are valid, and you want the number that are valid to be very small relative to the number that are invalid. The problem is quantum algorithms are in continuous time and continuous space. Like, all the operations are with some probability, like you do this operation and this particular state update happens. And the thing is, you're trying to make this like probabilistic statement, like after a certain number of operations with high probability, I've concentrated onto the valid states, like the things that are the private keys or whatever. The problem is sometimes those continuous processes, they'll always place some probability on the right answer. But generally, the hard part is showing that it's like the right amount of probability. And oftentimes, how you measure that is extremely difficult in quantum algorithms. Whereas in discrete algorithms, it's like probability is very easy, right? It's like I count one set of objects, I count another set of objects, and I divide them. I know it sounds very stupid to say it that way, but that is literally what you're doing in discrete land. But in continuous land, it's not quite that. And Guillermo hates continuous math, so like I point this out just more as he's a noted hater. He's a noted hater of probability in continuous space.
No, I hate measure theory. I did my entire PhD in continuous land and physics. This is BS.
But a lot of the quantum algorithm stuff actually boils down to like getting that type of stuff right, unfortunately.
I have thoughts about this because the state space is countable, and so we don't need measure theory. But that's a different. Maybe this is more of a philosophical qualm.
Yeah, but I guess the reason I bring this up is like there's two different cultures. There's like the discrete land cryptography culture, and then there's the continuous space and time quantum algorithms culture. And so like any paper that makes some claim like this has to use tools from both, and you need people who can validate both in order for it to work, which might take a lot longer than if you wrote something that's purely discrete or purely continuous.
Wow.
Mm-hmm. But that's more like a philosophy of science thing of like, oh, like how do you know whether a result is right or not, and like how many people do you need to validate it, whatever, like how many reviewers.
I think my version of this, which is just like standard Guillermo rant, is like, actually, we just don't have good abstractions for like quantum algorithms.
But I feel like that's like giving up.
I mean that in a positive sense of like, we should just make good abstractions for quantum algorithms. We just don't have them, right? Like right now, it's kind of like,
I do feel like that's throwing away decades of hard work people have done and saying, oh no, everything they've done is useless. Like it feels that, which I feel like is not worth.
I'm not saying it's useless. I'm just saying it's bad, like bad aesthetics. And I have a ranking of aesthetics Physicists are not at the top, and in fact, they're not even close to the middle. But happy to discuss further on that. I think cryptographers, funnily enough, are really at the bottom, actually, which is also kind of funny on this term.
See, again. But the Guillermo trash talk hour has started, right? Like,
clearly.
You got to have a little respect for how hard people work on certain things. And
this is not to say that that's not important or interesting or anything like that. I just think it's not bad
to say
aesthetics.
that your PhD and postdoc
Your
and
life's
20
work.
years of research aren't important. But
correct, but it's
you're
just
like
it's bad
you're
aesthetics.
like Kanye West, but for academics. You know,
Yes.
like when he.
I mean, hey, I'll take whatever you know. As much as I sling insults, I hope that someone slings similar insults back. Like this is not a one way road. But unfortunately I still think that I am right on this. This opinion is correct.
Amazing. So now I want to move on to another topic I wanted to touch on for 2024, which is applications and ZK applications. So one of the challenges with applications is that sometimes they may have been proposed in previous years, but only really become relevant this year, or maybe only really started to be used this year. So we're going to be a little forgiving in like the exact timelines for the applications.
Mm-hmm.
Like I'm trying to understand here what's really kind of emerged in 2024. What do we consider like the ZK application space today?
So if we're going to be lenient
Yeah.
on timelines, then I think we can talk about like ZK TLS. And I hate that naming for it, but like
Oh my
web
God.
attestations.
Web proofs?
Yeah, wait. Can just because like I don't know if you've done an episode on this.
We did an episode on web proofs.
Yeah, can we like disambiguate the term, because I feel like
Yeah.
it's a
I'd
wrong
love
term.
DKTLS specifically. So I haven't.
It's good explaining
Okay,
why
I don't
it's
think
wrong.
I don't think I've
Yes.
ever done a full episode just on that term, but it has been mentioned a bunch of times.
Good.
So yeah, what is the deal with ZKTLS then?
So the idea is you'd have some kind of plugin in your browser, or you have a modified browser that allows you to make proofs about a TLS session. And even actually more specifically in TLS, some cases it's like HTTPS. So it's like you go to your bank's website, it's secured with HTTPS. Great. Now you can make a proof that your account has a balance that's higher than, some number. The difficulty here is the cryptography that's used is symmetric. You don't have like this property, which is non-repudiation. You don't know for sure whether or not the messages sent between you and the bank were signed by you or by the bank, right? And so to convince a third party that it was the bank and not myself, we need to include someone else in this sort of proving mechanism. And that's like these notaries or these proxies or these MPC nodes. And so this is why I usually don't like the term ZK-TLS, because ZK usually refers to things that have a prover, a verifier, and the zero knowledge property, hopefully, if you're using ZK correctly. And then here we're actually talking about a protocol with a lot more parties. And so it could be a bit like disingenuous to people.
MPC-TLS?
Yeah, it's a lot more like MPC-TLS, or you don't have to use MPC. You can do this with like just someone that sits on the network between you and the bank. And then it's kind of like proxy TLS. And this is why talking about like TLS attestations is like, in my opinion, a bit more generic, doesn't have the downsides and the pitfalls of calling it ZK TLS, but also isn't specific about how you do it. I don't know what your thoughts are.
This is the kindest dunk I've ever heard on the podcast.
Hey, I'm not here to pick fights. I'm just here to decode
That's
some
where you're
jargon,
wrong,
That's what I do.
All right. Are there any other things that have emerged this year? I do have a couple.
I mean, if we're gonna pick fights, ZK VMs.
Actually,
Oh, yeah,
yeah.
that's-
So this is what I'm gonna say, which is the fact that a lot of people have gone from working on applications to working on ZK VMs is a sign that the search process to find applications has failed, and everyone wants to outsource it to people building stuff on their VMs. So then they end up building VMs instead of applications.
Well, I mean, we did learn this year that like fundraising for applications, ZK applications, has been hard. But I don't know if that's the fault of the state of the kind of application space or the fault of the funders at this time, just because like
I just mean that if a lot of people pivot to making a VM, you make a VM because you're like, so I want someone else to find the application and use my substrate, as opposed to like, I have an application, right? And so if everyone is going to a VM, that means the search process through the application space is not going very well. Mm-hmm. Whereas the search process in the VM space is easier.
You really don't think it's just because like there's more of an upside, like there's more of a business, like a case that investors like, and investors are kind of pushing these teams to create ZKVMs instead of using somebody else's?
I mean, if anything, I'd say it's harder to make money building a ZKVM than it is building an application, because you're now competing with a lot of other ZKVMs. Everything is open source, so it's very easy to like fork one and make your own ZKVM. Well, very easy, relatively easy compared to what it was like a year ago, 2 years ago. And so I'm not sure there is a business case to be made there.
Well, it reminds me quite a lot of like the L1 booms of yesteryear, or the L2s for that matter, where a team would have sort of like a really novel application idea and then go shop it on the market. And sometimes like tech was missing for them to truly build the thing that they wanted to build. And then they had to build down the stack. And then they ended up building more of the infrastructure and then just focused on the infrastructure. But other times I do think it was just like, I really do think sometimes it was just like, that was a more compelling business case for that team to be doing at that time than joining an ecosystem where you definitely get like a lower tier status. Like you can't, you're not the L2, you're not the L1, you're not the overarching network ecosystem anymore. You're part of somebody else's. I mean, I think a lot of projects have had that problem in like attracting app developers, which is like, I feel like the apps should be valued very highly, but they're still sort of seen as a little bit like a secondary, like, oh, it's part of my ecosystem. It's part of an ecosystem. Yeah.
Well, actually, I would dispute that a little bit in terms of other crypto applications that are not ZK, where there's a ton of them making a lot of money, like all these Telegram bots making 100 million a year plus. So like, all I have to say is like, I think if applications find a way to make money, they will do it regardless of the ecosystem, which is like what these Telegram bot type of things have been kind of proving. So I think it's just more like people haven't been able to get any traction, and the ZKVM is like a safe fallback because you know what you're supposed to be building. And if you have a particular vector direction of like, these are the things I want to change, then like you have a thing to keep moving on versus like getting stuck in the like, no one wants to use my thing.
Yeah, it's kind of funny, but it's like, ZKVM has like, feels like it's become like a well-trod path versus like the applications, which is kind of an open thing. And it's like, okay, cool. If we build a ZKVM, we'll find maybe some applications, someone will figure out some applications for it, versus being like, okay, but
it's funny because this all happened this year, which we're saying of like building a ZKVM is now an easy task.
Yeah, true.
Happened this year. Up until like end of 2023, there was maybe just RIS0 doing sort of RIS5. And now we have plenty of them.
Yeah, so when I say like easy task, I don't mean like easy in a physical sense. I mean easy in like the spiritual sense of like, this is now a thing that like is a thing, right? Yeah. I know it's a kind of wooey or whatever, but it is like a thing that people now do, right? Which is a funny thing to say about like such a kind of niche esoteric topic. Yeah, relative to not in crypto, but just in the rest of the world. Like,
but don't you find that when a project, when a category reaches that level? Like, for example, I can't remember what we said last year for 2023. I was telling you this, Guillermo. I didn't have a chance to listen to our episode, so I don't know what we said, but I'm pretty sure we would have mentioned coprocessors last year. Because that was...
we did. I'm pretty sure. Like, I can even look it up.
The idea emerged, and then within a few months, a few other teams were doing it. And then by the end of the year, there was like a list very, very long. And I think a lot of those teams have since sort of like that's their application, but they've moved a lot of their effort into like another part of the stack that they're building.
Well, that's what we just saw with Axiom, right? Announcing OpenVM. So Axiom started out as a processor, and now they're leading one of these like VM efforts.
That's crazy. I actually didn't know this. When did this get announced?
Yesterday.
Okay, fair. I'm allowed not to know that. Yes. I feel like I was completely out of the loop. I was like, what? Okay, yesterday.
No.
A lot of other coprocessors then ended up moving more in the prover network side of things. And like prover networks, we definitely talked about at the end of last year. That was when we were first seeing those projects emerge. But in the last year, we've seen a lot of teams that had sort of initially pitched themselves as one type of application include a prover network to like widen their offering, basically.
My only thing is just like, I think like the answer to your question is there are no applications. I love you. It's like, it's literally the like, that's what 2024 was to me.
Ooh.
I mean, there's one. So actually thinking back to our predictions that we made earlier this year, we were talking about like identity stuff. and
Yeah.
scanning passports. And that's actually something that has been built a lot this year.
True.
There's a lot of different teams that have been able to scan passports and make ZK proofs around them. The application built on top of it, I haven't seen many. We had heard of, I think it was the Rarimo team using it to do like shadow elections in specific countries. I think Aztec, some of their early wallets are looking to integrate this like from the very beginning in the wallet. But I don't know if we saw yet like fully fledged identity systems and identity applications. We're on the way.
Nico, you and I talked a lot about this in sort of the last episode of the regular weekly cadence. We did a look back at some of the events that had happened. And we mentioned the cursive presentation at ZK Summit. There's some really interesting ideas, but this is in the, like, to me, that's in like ideation phase. Although they are doing experiments with all of these. So like you might get a chance to use this, but it's not like it's in production yet in any sort of like large scale way.
Yeah, but I guess that's exactly the kind of application research that Tarun was mentioning that some others have tried and haven't been fruitful with. And hopefully some team will find something eventually.
I mean, there are few things that have popped up, but I don't know if they fall under the application category exactly. But things like Celestia ZK accounts, there's all these BTC ZK rollups, which is not like new, but it's different. I mean, it's like rollups are not new, but they're using, I mean, they're going about it in a different way. And then co-snarks, which is obviously more like an infrastructure piece. It's not an application per se, but I mean, at least in the conversations, it sounded like that could open up some cool things.
I would say one thing that hopefully will come out of all the VMs, a little bit like your analogy of like the 5 million L1s, is like, the VM that you don't expect will win if it's like the L1s, right? Where it's like...
The Solana?
Yeah, exactly. It's going to be like someone who you don't expect, but who like builds better developer tooling. And then the other thing is like, I'm just hoping people kind of like upstream ZK into already successful applications versus like trying to build totally new ones from scratch. Like use ZK tools as like features within existing applications that already have usage. You're kind of starting to see that. And my prediction is like 2025, we might actually start seeing that way more, where it's like ZK and Ts are somehow added to already useful applications as opposed to like totally built from scratch around the privacy preserving or succinctness features. I think like we're going to have a flip from like, oh, the application has to be about ZK or privacy or succinctness or etc. And it will be like, those are features that make an existing product better. And I feel like that is the direction we're moving in, but I could be very wrong. That's just my kind of rough belief.
Yeah, on that point, I feel the same way about ZK as I do like about blockchains. Just like fundamentally, it is like a cool, insanely sick, like fucking wild technology that is possible. But otherwise, like nobody's debating, what database use. Like no front-facing consumer gives a shit about like what database you're using in the back end of your like application, right? Like you're not like like use MongoDB. I'm not going to use you because like that. Sorry, like. Fundamentally, it is like a boring
you're
technology.
Against my values. Yeah.
Yeah, like it's just like a boring, like a very fundamentally boring technology for it's like, okay, cool. Like, yeah, we use this like cool cryptography stuff to ensure that my privacy is preserved. Sick. Like, and it is very cool. Like for what it's worth, it's insanely cool. Like the fact that we can even do it is insane, but it is not the point. Like it's kind of like an instrument to like doing the thing rather than like the thing itself. And so with Tarun's point, I think it's a healthy thing to see where it's like, cool, like the tooling has become good enough that I can just like incorporate this in the way I want or the way I find interesting into the app. And I never have to think about it again, except insofar as it's like the properties I get are cool or useful or whatever.
I just realized, Guillermo and Nico, you guys released some work recently, and I don't know what category that falls under.
Yeah.
Is that an application or is that research?
I have no idea. I'm glad
That's
you asked.
a great question.
And I do think like we probably deserve a lot of time and space to really dive into what you guys have recently released. But do you want to just quickly summarize it, and then we can maybe do like a full episode on it sometime soon?
Okay, I'm gonna give a quick setup and then I'm gonna say a thing. So there is like this funny thing that I've been ranting on, and I believe I've done it here on the podcast, which is, right now we have kind of multiple ways of building like zero knowledge proofs, one of which is we use a VM, a ZK VM. Another one is, I'm sorry, when I say ZK, I mean ZK in the like royal sense of ZK, the like lowercase ZK. So succinct proofs. And I've been ranting about like, look, there are things that we use all the damn time, like literally so much that it is unbelievable that we are going to just eat all of this overhead to like prove that a certain thing was done correctly. So in the case, let's do the case of Zoda. It's like one of the things that happens a lot in Celestia is we encode some piece of data, right? And we would like to show that that encoding is in some sense correct, or close to correct, or whatever, right? And the first thing you say is like, cool, like we have this very sick and cool proving system, which is either ZK VM, or we have like a general proving system where we like build some circuits and you go and like press enter and you generate your square, right? Which is, takes like a second on a laptop. And then you press enter on the, ZKVM or ZK proving system, and like let it run for many hours. And then out comes a proof that like the thing you did was correct, right? But the point is the difference in time that it takes you between doing the thing that you care about doing, which is a few seconds, and proving that that thing that you just did in a second is correct is like 1,000, 10,000, 100,000x. So
more time?
Yeah.
Oh,
more
okay.
time.
Yeah, that's
right?
bad.
So like proving the thing is like somehow, even though it's kind of an incidental thing, like I just want to show you that what I did was correct. Like now it takes like thousands, 10,000s, hundreds of thousands longer than just like doing the thing itself, which is kind of silly. Wow. And yeah, it's easier to prove, it's easier to verify and stuff, but fundamentally it's that. So one of the rants I've always had is like, okay, in some sense, there are certain, it is easier to build on a ZKVM, which is why everyone's building ZKVMs. So, but you should be able to kind of go down to the bare metal. And for certain very important applications, we should be able to construct specific, proving, I don't know what to call them, and like not a system because it doesn't prove everything, but like a specific algorithm such that like the amount of time you spend doing the thing and the amount of time you spend proving that what the thing you've done is correct is very small, right?
Cool. And that's what you guys have built.
So specifically, yeah, in the case of DA, we've built what we think is the first like purpose-specific succinct proof, which actually does a thing that like people are using right now, like they're doing right now in the case of data availability, which is we want to prove that like something is not just like close to correct encoding, but indeed it has this tensor property of this like weird encoding, and it has these like additional data availability properties or whatever.
Yeah, just to be clear, like not exactly the first ERMO, right? There's these great papers from Ethereum Foundation, like Benedict Wagner, Mark Simkin, and I think Matthias Hall Anderson, who look at this problem. But the way they do it incurs like a constant overhead cost on the network. So in their system, like the network is going to be sending the same thing to every single light node. Whereas we sort of relaxed a bit the definitions, looked at it, maybe I'd argue a bit more holistically, and realized we could get rid of that overhead. And so that's sort of the main point of the work.
Cool.
Correct, right. Yeah, so we're not the first ones to do it overall. I think we're the first and specifically is to do it in a way that's zero overhead, where constructing the proof and having done the thing takes the same amount of time and takes the same amount of space. So, which is weird and like not obviously you can do. Anyways, that's a whole other thing for a later problem we can talk about.
Another episode potentially.
Yes.
Very cool. So now I think we're almost at the end of the 2024 look back. There was one point I did want to cover, which was, were there any technical barriers or challenges that the ZK space faced this year? I think 2022 was the OFAC sanctioning of Tornado. Last year, I honestly can't remember what the challenge was, but I'm sure we said something. Earlier in this episode, we actually brought one up that was at least suggested right here at the end of the year, which is quantum computing will ruin elliptic curve cryptography. And I have to be honest, like I slightly fell for it. I thought like, ooh, maybe this is a thing.
I mean, we know it's going to happen, right? It's just a matter of timeline.
It's when.
And yeah, I think we still have a lot of time.
One thing that oftentimes happens, I think, in research where you have to build physical devices is if it's not really a general purpose device, it's built around solving a particular problem really fast, but it might not be particularly fast for other problems. Like maybe the only problems it can encode are like things that are represented as an Ising model. Well, a lot of computations, if I have to embed them as an Ising model, it's extremely slow, gigantic, high overhead, etc. Right? Like, so my point is, like, there's a lot of devils in the detail to like how the device is implemented, what it's built around being used for, what the benchmarks are, and how its real world performance on like lateral problem solving, like problems that aren't exactly the one thing it was designed for, work. And generally the quantum Fourier transform / Shor's algorithm type of stuff is not the benchmark everyone cares about. They generally care about these like hardness circuits, like these like worst case circuits. You know, for the cryptography audience, if you've ever studied like IO or garbled circuits, you could think of there being a quantum version of that represents like a random garbled circuit, and you need to like solve something that looks like satisfiability for it. That's considered the gold standard, or like the hard to prove that you've done something that a classical computer can't do. And those types of things are very different than the practical things. So you might have built a device around like winning the benchmark, like beating the benchmark, but that device might actually be still kind of not super practical for doing like finding Satoshi's keys.
But isn't there motivation to, and not because, I mean, Bitcoin keys is like the least of, it's like, think about all sorts of encryption that would like destroy states. You know, like I feel like, is there enough motivation?
But most of the positive usage of quantum computing is not cryptography related, right? Most of it is simulating physical systems really quickly and doing kind of like the stuff that when Guillermo was my intern in 2016,
That's
like,
right.
yeah, like the stuff we were working on, like you could do that like 10 to the 15th times faster or whatever, right? That's kind of like why people want quantum computers. So Google's actually focused on the science side much more than the cryptography side. And that's also why I think like I find the marketing aspect of it very unsavory. Like I get it, but the idea that your CEO is going on TV saying like this proves the multiverse exists is like a little embarrassing to me. It's
Did they
just
actually
like
say that? This is that's actually wow.
You go read
painful.
the blog post. It's like it is embarrassing.
Is what they
It's like,
released
no.
actually a thing? Like, so maybe the marketing's wrong, maybe like, but is it a first step towards something, or is it all fluff?
I mean, I for what it's worth, I've only like very casually read the stuff. I was interested in quantum computing during my master's and part of the PhD, which is the reason why I did some of the stuff I did. But I mean, I'm sure it's like a nice step towards the same things that everyone has cared about for a while, but it is a step. It's not obvious to me that this is like an enormous. I think the biggest thing that was very interesting was kind of a positive claim that they made, which has kind of fallen by the wayside, which is this. In quantum systems, there's a big problem with errors that kind of they get accumulated in the system, and at a certain point, your signal becomes mostly noise, right? So you can't use it in any like useful way if like too much noise gets into this like I don't want to get too much into details, but if too much noise gets into the signal, right? And then the point is like what they showed is what normally happens as you make the systems larger, you get more error.
But here, because of error
What's
correction,
weird,
they were able to like not get more error or like less.
But it's not just that. So what's interesting is here, as the system gets larger, you actually get less error. And that's what's
error
weird.
is what you're saying, right? ERROR.
Like error, like
yeah.
Not
air.
Yeah. Not
Yeah.
air. Yeah. No, not air
Okay.
like generic oxygen or like nitrogen mixed with oxygen.
or
with
stark
argon.
airs.
Yeah. You don't want to no naming
Arithmetic
confusions here.
intermediate.
Okay.
Yeah. So what was weird. That was like what was like, oh shit, this maybe is like very.
Do you know anyone
real.
who's like checking this, or like how does this get verified?
the
There's
fun
a lot
part
of
about,
trust me, bro, in hardware. Like that's just a fundamental truism, right? It's like you can't really verify the hardware.
The fun part about physics is actually just it's shocking how much of it does like not reproduce. Which is very weird because everyone holds physics as the golden standard of reproducibility. Because in some sense, yes.
You used to not be able to become Stanford's president by faking your results for 20 years. Unfortunately, that's true nowadays.
To be fair, that was like biochemistry.
Yeah.
I know, but like I mean, it's a societal value thing. That like
Other challenges and setbacks. I'm going to just say, like, I think we just highlighted one, which was like applications almost like reverting back to infrastructure, which was not something we were hoping for this year. We were hoping to see like standalone application. Is there anything else?
Yeah, I found that competition got a bit nasty.
True.
Maybe it already was, but it got a bit nasty.
It always was. It just wasn't on the surface.
Well, it always was. It was just in
and some
different
of the
categories. Like the L1s or the roll-ups was last year's battle, right?
Yeah. But communications got a bit nasty around it, and that's, I think, unfortunate for the whole space. And I think it is a challenge moving forward. Like, how are we going to make sure that
Well, it may just be
again?
the nature of the size of the ecosystem, sadly, and like the money on the line. It attracts more of that, I think. Tarun, you had sort of hinted at the roll-up roadmap in our pre-conversation here.
I basically think, like, fundamentally, and like I'm biased now because I'm writing some small note on paper on this, but like there's actually this fundamental annoying problem about rollups, which is if I have a system that has n rollups, in the worst case, the amount of transaction demand that I need to make up for the lost revenue to the L1 grows with the number of rollups. So like in a world with 1,000 rollups, I basically need 1,000 times the transaction volume to compensate for like L1 lost revenue due to congestion.
Which makes total sense, and so, actually. Yeah.
It's sort of like, you're taking away all this MEV auction stuff, which pumps up the revenue. Like if you look at Solana, where like the revenue's huge from that. And if you look at how much competition you get from having all the rollups, you sort of get this like lower bound, which is like kind of annoying. Wow. So I think that the idea that there's going to be 1 million rollups and you're going to need, the services sold to the rollups like DA and stuff are going to be valuable is like a lot harder of a claim to make in 2024 when, you look at the rollups, it's concentrated to the top 3 or 4. It's clearly not like the rollup ecosystems haven't figured out how to like not just be tricycles that happen to have a bridge, a validating bridge to mainnet. And I just generally think like there, as great as, a lot of things that are within Ethereum are, like there is a sense, and like this is sort of like one of the reasons I've been thinking a lot about this and writing about this is like this, everyone on Twitter will be fighting about, are rollups parasitic to Ethereum or not, right? Are they removing all the volume and demand and then no one wants to hold the asset, whatever? There's a sense in which it's true, but only if the transaction demand for the whole network is below some threshold. And the problem is we're kind of below that threshold. Like we don't have enough demand to justify. If you look empirically, it's like kind of weird. And that's why you see kind of, I think, the success of like the Solana and Move type of stuff right now compared to some of the things in Ethereum.
Although this isn't
but
ZK
it's not
specific.
That it can't change.
This is just like one of these.
This isn't ZK. This
ZK
is
rollups.
But I think the ZK rollups have an even worse version of this, right? They have a higher cost basis.
Yeah.
To go hurdle rate. They have to like have all the proving working. They have to have that be cheap on top of all the other things that the current ones have. So that means they need even more transaction demand. And if you look at them, they have much less.
Don't they make money through like these provers, like having doing proofs on chain kind of?
Okay. So
or don't they cost
I think like
more
the
or like
world,
make more for
does,
the L1? Yeah.
The real question is will ZK get more, in my head, and this is sort of like a like, again, more philosophical question, but will ZK get actually used in applications when the cost of proving is, and the actual proof generation is the valuable part, or will it actually get used when proving basically costs zero?
So you're saying like we're heading towards a zero cost anyway, so like it won't.
If we're heading towards zero cost, that's how you get distribution. And so like it's, but I do think the ZK rollups that are live now are in this weird kind of catch-22 where it's like the cost is high now. So like they have to somehow get more transaction demand than like Base or Arbitrum. And like that seems very unfeasible in 2024.
The hard part for me is like betting on ZK costs remaining high and then people paying for it like feels very much like betting against the improvement of technology and the improvement of like proof systems, which like if we've learned anything over the past like literal 4 years is that those things feel like they're going to zero extremely quickly. Maybe there's some fundamental limitation why this time it's different, and like all the stuff. But I do have a hard time with this. It's like if you're depending fundamentally on like the economics of proofs, like costing some minimal amount, like I feel like I have bad news against betting against technology. Like we have literal supercomputers in our pockets.
This puts into question lots of projects actually, because aren't prover networks sort of like based on that too?
I'm not saying they won't be valuable necessarily. I'm just trying to
Correct.
say the following statement, which is like in proof of work, the value of the hardness of the process is important to the network.
That's right.
It's in fact one where like by not adding in new technology to the network,
That's right.
You're kind of making the creation process more valuable. But in everything else where it's a technology thing, if the technology improves, the cost has to go down. Like it shouldn't be that like the cost goes up to keep participating in the network. And so there's this trade-off between those two tensions, right? These are claims that are like in infinite time and infinite resource world. Like you could spend as much money and as much time to get to that advancement. So there's obviously going to be some time period where that's not true. But where those two kind of things meet, where the production cost is as valuable as like the consumption cost in some sense, is like the thing that you're predicting. And I just sort of think ZK has like a weird cost curve right now, where it's like and like unless it can increase its transaction demand like 1000x, it's like it does seem kind of like it's always going to be at a loss to the non-ZK versions, at least for rollups, just for rollups.
So we just have a few minutes left in this episode, but as I had said at the beginning, I really want to touch on 2025 and what could be coming in the ZK space for 2025. Predictions, people. Don't we love them? I, again, sadly forgot to check last year's, so I may accidentally say the same thing again. I have a feeling one of those would have been more applications in 2024.
Yeah.
And I would, at least like in a hopeful sense, pitch that forward. But yeah, what do you think is coming up in ZK in the new year?
I think for me, it's more of a wish list than a prediction. But I want to see proving for people, no more proving for big servers, for rollups. I want to see proving for people. I want to see it happen on your phone, or if it's not happening on your phone, I want to see it delegated privately.
Yes.
But yeah, I want people to actually build on phones. Kind of in the same way it's easy to fall back to building a VM, it's also easy to fall back to building proof systems or applications. Well, no, tools. Yeah, for big, beefy servers.
Yep.
It's harder to build them for phones. That's my number one item on the wish list. And I think that's also what a lot of people are going to be targeting.
Yeah, I mean, I think I had this prediction last year too, which is like client-side proving. Like, come on, like, what are we doing? Like, what are we doing here? Like, this is supposed to be privacy software, not like SaaS, right? Like, we don't need a rack somewhere to like do the things for us. We have supercomputers in our pockets. We should just use the supercomputer in our pocket to do the thing. Like, come on. Anyways, I'm very mad about this, and I agree.
We want to put the ZK back into ZK.
Correct.
I see 2025 as being a time of certain kinds of like, almost like the experiments and pitches from 2023 and 2024, I hope go live enough that we get to see if they work or not. So these include some of these categories we talked about, like the coprocessors, like the prover networks, there's the verification aggregators. Like these are interesting, but they've felt so far somewhat unproven. The economics aren't as clear. Exactly how they interact with the different systems they plan on interacting with isn't completely clear. How many there should be, if there's even a market. Like these are kind of questions that I feel like I've been having for many, many months and maybe like more than a year. And I'm hoping that in 2025, we start to see the answers. It's not to say they'll be good or bad. It's just like, that's kind of what I'm hoping would be like we get some sense for these things.
I'll give one instead of a predict. I gave, I guess, an earlier prediction that like an existing application will be a better user than any new application. And I count rollups in the new application. But let me tell you, the most successful usage of cryptographic techniques in terms of a money-making application in crypto this year.
I know what you're going to say.
Take a guess, each of you. You get one guess.
I think is it a project I'm not a big fan of? Okay, no, then it's not what I thought. Okay, it's not what you would have known what I meant. Okay.
I don't think. I actually don't. Okay. I don't know. I don't know your opinion.
Although I
really?
do think it is that, but well, for me. But
okay, guess. Give me your guess.
Total number of proofs.
Like economic.
Like
no. In terms of using cryptographic tools on a mobile phone for an end user,
it's WorldCoin, isn't it?
I think WorldCoin.
BonkBot makes way more money.
What?
BonkBot is done completely in TE.
Oh.
On mobile devices. made $300 million last year.
Although
Holy shit. Wait, that's incredible.
Yes. You should read the BankBot TE architecture. It's actually quite, I was quite impressed.
Hilarious.
For like something that's like doing meme coin trading. So this is where my point is that like all the stuff that like people are spending money on, I think eventually you'll get the seep in of like mobile privacy. Especially as people are using way more mobile apps for crypto. Like as weird as it is to say, no one has gotten more mobile app usage of wallets than meme coins, which is like kind of scary and sad at the same time. But
fast stock trading. It's like Robin Hoodie. What's the worst outcome for ZK in 2025? What's like a bad thing that we're afraid of?
Rollups are the only consumers of proofs.
No applications.
I mean, it is a worst case outcome, but I don't know. Like for me, the probability that happens is 0.
You haven't talked to enough ZK VM teams. They all think that rollups are the best customers.
No, they're by far the worst. Like, I don't know. I find it hard to believe that we're not just going to be like slinging proofs from our phones all the time in the next like 10 years.
I also do think it might be.
But he said next year, not 10 years. Next year.
Oh, next year. Okay, fine. Yeah, maybe next year. Fine. All right,
I'll give another best one. A best one would be like, well, kind of best. I don't know if this is that great, but like some existing huge monolith technology company starts to be deep, like ZK becomes like a deep part of their stack, which is exciting because it would be like, then the number of people touching it would be very cool and like this tech would go further. The bad thing is like, obviously the whole spirit would change potentially. And like the focus, like it would almost be like that company could almost absorb all of this work we've been doing, building out, the ideas around this, and then just kind of like take it sort of as their own, which would be a bummer.
I mean, you were in music before, Anna, so maybe this analogy is going to help like resonate with you. Like when you're in like underground indie circles, you love the kind of music you're doing and you want it to be pushed out to as many people as you can. But suddenly when it becomes mainstream and when like mainstream music sort of appropriates that kind of stuff, it becomes uncool.
Totally.
And it is what you wanted in the first place. But then when you get it, you're very sad about it.
That is so speaking to me. Like, I completely, underground from the 90s, indie from the 2000s.
Yeah. I think we should be okay with it. I'd be happy to see it go mainstream. I'd be happy to see, Apple wallets have a crypto wallet in it and you can sign with Face ID. Wow. Super great. Uses TEs on the device already. Wonderful. Yeah. Kind of sucks for the indie developers, but it's good for the end user.
Yep. There may or may not be at least one large company doing this, but it's fine.
Yeah, I feel like there already are. Like Cloudflare, I know.
They always have, though.
I would actually put money on Cloudflare.
But they
using
did. They always did. They just used it in a really tiny way.
But I as in like using more, like using recursion, for instance. Like I would actually, if anyone uses it first, it's probably them.
Another worst outcome then is like a very bad big project or big company or big entity or state or something using it. Like maybe that would be the opposite.
It's permissionless, Anna. There's no good or bad here.
Actually, worst outcome, some kind of like huge breakthrough, but gets patented. And then like, no one can use it.
That's what I worry about FHE for this, by the way, guys. Too many patents in FHE. Not going to name names, but someone...
Yes.
I think they might kill their own industry if they don't like open it up a little bit more. Is there anything you guys want to share about like what's coming up?
For me, nothing specific. Just more research, hopefully.
Honestly, just like... I feel like I've spent the last year falling out of closer to cryptography stuff and getting back more into DeFi. So I think that's because I think it really is back.
DeFi pilled once more. Before we sign off, I just wanted to share a bit about this show as well, because as you know, we've been on break and we haven't been releasing as regularly, although we have released one a month, which is cool. So yeah, the plan is, after taking a bit of time off, I had a chance to, get a little bit of inspiration going. A lot of these new use cases and directions, these are things that I've been reading about. And so I'm really excited to come back to these interviews and to start up the show again. The plan right now is to start releasing again around mid-January. I don't have anything scheduled yet or recorded, so maybe we have to push that back by a week, but that's what we're looking at, sort of mid-January. I'm still not sure if I come back weekly, like every week all the time, but I'm sort of playing with the cadence, and we'll figure that out over the next few months. But yeah, I mean, I feel like taking some time away, what it made me do really was it made me start to miss these interviews, and obviously seeing you guys, my co-hosts, but also digging into these topics. I find it always very challenging intellectually. It's broadening in a lot of ways instead of sort of narrowly focusing in on my day-to-day. It's really great. I think one of the challenges I've had is like being super, super hands-on and operational on the events front and running these 3 companies. But yeah, I think in the new year, I mean, I have an amazing team around me with Gaylord and Quentin over at ZK Hack, Agni and Rachel and Henrik and everyone over at the podcast. Also the entire ZKV team who's really rolling right now. So I feel like, yeah, in the new year, I'm going to be able to focus more on these episodes, which is something I really want to do. Okay, and then I have one last thing I want to share, which is about the events coming up. So in the new year, in 2025, there's already 2 events planned. One on the ZK Hack front, which is for ZK Hack Seoul. This is going to be in Korea, right around the Biddle Week. So if you're in that part of the world, in April, the event will be happening April 11th to 13th, right after ETH Taipei, right before Biddle. And so if you're there, please join us. If you are one of the ZK Hack community members and you've been at all the hackathons, I hope you'll put that in your schedule for the new year. If you have never been to a ZK Hack hackathon but really want to check it out, join us as well. Korea's pretty amazing. I've been there once and it kind of blew my mind. I think it may be, one of the coolest places I've ever been. So it's very cool to get to do an event there. The other thing, and maybe more relevant to this audience, is ZK Summit 13. We have our location, we have our dates, and I'm very excited to share this with all of you. The ZK Summit 13 will be happening on May 12th in Toronto. This is the first time we bring the summit to Canada and the second time we bring it to North America. But the last time we were there was in 2019. So this is pretty exciting to be doing a ZK Summit in North America. Yeah, it's happening right around the Consensus event as well. Just so you know, though, we actually found this location and scheduled this before we knew about that. So it's not meant to be kind of piggybacking on that, but it just kind of worked out that way. Yeah, so I hope I'll see a lot of you there. Put that in your calendar. Just so you know, though, we won't even be opening applications or anything until February. We want to get sort of fresh research for the talks. And also just generally, we tend to do that in more of like a 3-month window. But if you're going to be there, if you're planning on being there, just put that in your calendars already. And stay tuned on all the channels because that's where I'll be sharing more. All right, guys. Thank you to all of you for joining this sort of finale to the year on the ZK podcast, this special episode where we looked back and looked forward. Yeah, thanks for being on.
Thank you.
Excited to be here.
Thank you for having us.
I want to say thank you to the podcast team, Henrik, Rachel, and Tanya, and to our listeners. Thanks for listening.